like I said, I'm the VP of Architecture for Amino. If that name rings a bell, it's probably because Dan, our VPE, did a presentation for you guys a couple of months ago. That's probably why you thought that I presented. Dan presented.
Oh, sorry.
No, it's all right. It's all right. His presentation was more about our overall platform and value prop, but this is going to be talking specifically about Hyperledger and our experience with it. So for those of you who either aren't familiar with us or who don't remember really what we're about, I figured it was probably worth doing a really quick sort of shallow dip into what we do just to refamiliarize you with what we're about. So most people think ads, buying ads on the internet works like this, where some brand wants to get their ads out there on some site. They interact directly with that site. They pay them some amount of money, and some number of ads are shown on that site. But that's pretty far from the truth. The reality is a lot more complex. So since we've got so many brands buying and so many publishers selling, they needed to have technology created that would allow them to more efficiently buy and sell those ads. And so we ended up seeing the emergence of these middlemen here in the middle, the DSPs, the demand-side platforms aggregating buyers buying, and SSPs on the right-hand side, supply-side platforms aggregating sellers selling. This is all well and good. It solves that particular problem, but by disconnecting the buyers from the sellers and creating these hops in between, it creates an environment that sort of encourages shenanigans. Yeah. So the first of which is there's no source of truth. I've got my numbers, you've got your numbers, and we fight about it. There are discrepancies, that's what we're fighting about. We're fighting over who owes who how much. This creates a very long, drawn-out process on what would normally be, let's say, a net 30 relationship, suddenly becomes net 60, net 90. It's not unusual for it to take 6 months for folks to get paid. And the joke in the industry is that it's net never, because you can literally create a very successful ad tech company, but because of how long it takes for you to get paid, you can go bankrupt. In addition to all of that, as you can imagine, by being able to hide in the middle, you've got some companies that take advantage of this, creating waste, fraud, and abuse in the process. The end effect of that is for every dollar that's spent by a brand, only about 30% of that makes it to the actual publisher, and as much as 20% of that, it's believed, is eaten along the way by bad actors. So when we approached this problem, we knew that we wanted to have impression level accuracy, but we also wanted, bank-like security. And so a lot of what blockchain had to offer was very appealing to us, but we also wanted ad tech speed, and that was a challenge because we also wanted to have a shared ledger, some kind of database that these different parties that don't necessarily trust each other could interact through, which also means that we would need some kind of smart contract component so that they could manage their relationships. So when we broke it down, how we solved that problem or addressed those needs, we did what most people are doing now, which is the stuff that we needed really fast, we did all that stuff off-chain with a centralized ledger, and by sort of keeping it within our shop under our umbrella, we were able to achieve the ad tech scale that we were looking for. It's not as cool, but it works. We do use digital signatures and things of that nature that are very blockchain-like to maintain the provenance that people expect so that they are sure that they're buying from who they're expecting. But it's not full blockchain yet, or rather at that point when we're making these decisions. But it's actually still really cool even though it's not pure blockchain. But we did need a shared ledger. We knew that they wanted to share their data. We knew that it needed to be kept private. We knew that they would want to have automatic reconciliation because that's one of the issues we talked about, how that's a real pain in the neck. Payments settling automatically, and of course to achieve all that, some kind of smart contract to manage all that within the ledger itself. So when we thought through this whole process, we ended up asking a bunch of these kinds of questions. A friend of mine sent me this is a great PDF, and we're going to share this out to you guys so that you can click all these links that you want to dive into this stuff a little bit deeper. A friend sent me this after we'd already made these decisions, but I felt like this was a great way to sort of encapsulate very succinctly the process we went through to make the decision about what kind of blockchain we wanted to use to address our needs. So, did we need to store state? Yes. Arguably, if you don't even need a database. Are there multiple writers? In our case, definitely yes. Could we use an online trusted third party? Well, we're supposed to be that third party, so we couldn't use someone else to address that for us. Are all of our writers known? Yes. If not, like we don't really, because we're dealing with institutions instead of individuals, anonymity wasn't really a feature we were interested in. So the answer is yes. Are all writers trusted? Mostly, but not enough for us to just let them have access to this and sort of duke this out themselves. So no. And is public verifiability required? In our case, no. In fact, the idea of having any of this data public, since this is essentially the ledgers that these companies share between each other, that was sort of anathema. So the answer for us was definitely no, which means that in our case, we wanted a private permission blockchain. So having made that decision, we had to explore our requirements to try to figure out what specific blockchain we were going to choose, or what platform or technology. We knew it had to be a private permission blockchain. We didn't want to have to deal with cryptocurrencies. Our clients wanted to deal in dollars only, and the volatility with Bitcoin and other things scared them quite a bit. It scared us. We wanted to have something that had an active community because we're a small team and wanted to lean on a much larger group to provide a lot of the development of the platform itself. We wanted to make sure that it was business focused, that they were addressing the same concerns we had, so we didn't have to build that part of it ourselves. And so on and so on. Needed to be cheaply scalable, so complex or CPU intensive consensus wasn't really an option either. And we didn't want to have to learn anything new. Not because we're lazy, but because we don't have enough time to learn this. Some of these are fairly involved, so we wanted to keep that as simple as possible. And we knew that because of the shared ledger, there'd be some kind of smart contract for the automated reconciliation. So really at the time, the only thing at the time that satisfied all those criteria was Hyperledger. We've got some links here to for deep dive to the architecture for those of you who want to really climb down into it. The consensus was very simple. It's permission voting, so as long as you achieve some kind of threshold for the endorsers, I think it's like 70% by default, then it automatically gets applied. It's got BFT to sort things out on the orderer side of things, and it's pluggable, which is nice, because even if I don't like the first two, I can change it to whatever I want. The transaction flow is a little bit different. In order to make it more scalable, they sort of separated the endorsing from the ordering and from the actual data stores, the peers themselves, which allows you to sort of scale the parts that are slow. And it had the scale we want, which was in the thousands of transactions per second. So, first steps. Standing this up in our dev environment, this whole process was very, very quick. The initial prereqs before you get to actually installing the real components, just about everybody probably already has this on their machines now. MVM, Node, Docker. Then the actual components of Hyperledger itself. So it's worth pointing out at this point that we weren't just using Hyperledger Fabric, but we were using a layer on top of that called Composer that they released. And it really simplified a lot of the process of talking to our blockchain. It's also partly responsible for why we didn't have to learn a new language. It's in JavaScript. You can write your chain code in JavaScript, and it gets compiled down to whatever the native underlying language is. So these are the parts. You got the Composer command line interface, Yeoman, which takes the templates generates the templates for Composer REST server and the Composer Playground. You've got the REST server itself, which is basically it's a convenience because it allows you to communicate. Everybody in your team doesn't have to learn how to communicate with the blockchain. It provides a Swagger kind of RESTful API that you can talk to do most of what you need to do without having to be an expert talking to the underlying technology. The playground itself, which we'll get to in a second, and then some VS Code plugins, which are optional. I use IntelliJ, so they weren't really useful for me. And then Hyperledger Fabric itself. So we stood things up fairly quickly. We got it basically up and running in an afternoon, which was pretty fantastic as far as just standing up the platform without any of us writing code yet. Here's a breakdown a little bit further into sort of the ingredients that go into creating a business network definition. You've got the model file itself, which is fairly straightforward. It's a little bit JSON, a little bit YAML in terms of how it looks. The transaction files themselves, the actual chain code, is in JavaScript. I believe it's ES6, so that's pretty straightforward stuff. The access control rules, that's a fairly complex, it supports very complex rules if you'd like. Ours right now are wide open because we're the only ones accessing our particular instances. But you can, it's granular enough that you can have access control down to the record level, which is nice. And then you can have query definition files, which allow you to create views to make some of what you've got going on in the transaction functions a little bit simpler. So when you first fire up Composer Playground after you've run through installing those other components, you just hit the login screen. There's a default business network that gets set up when you first fire this thing up. This is ours right here that we've constructed. Again, once you get into it, so if you click Connect Now, once you've set up the initial connection information, it takes you to this screen. It's very easy to set all this stuff up. This is basically, if you click there, this is what you see. It's a package JSON. So if you've done any node development, this should look very familiar. The model file, like I said, this is very straightforward. It's very intuitive. The assets are basically anything that's an asset is something that's going to go in its own asset registry. So those are the things that actually get written to your blockchain. And then you've got the idea of concepts. So if you need to have more complex data structures and you don't want to have them all sort of lumped into your assets, it gives you a way to sort of conveniently create those structures without having to have completely separate asset registries for each one. This is where you'd put your chain code. I've pulled mine out. You don't need to see it, but it's very easy to write. Like I said, it's in JavaScript. Here's an example ACL file for access control. Like I said, in ours, it's wide open in this example. So we got our initial set of models set up. Again, we did this in just 2 or 3 days. We wrote some chain code in JavaScript and began testing the code that we had written. We did run into an issue at that point. It was at version 0.16, and at that point, that was duct tape based. For those of you who are familiar with that, it's basically another kind of JavaScript engine. It's not Node, and because it wasn't Node native, it really didn't have access to the file system, which meant that since there were 6 instances, there were concurrency issues. It was very difficult to manage whether or not you were reading or writing to a given asset on a registry because the threads had no way to talk to each other. So we had some issues there. We had to back out some of the complexity we had in our initial pass through this. But most of what we wrestled with is a thing of the past. My understanding is that in 0.19, which is the most recent version, it's fully node-based, which means you've got access to all the stuff you'd expect and can manage concurrency in all the ways you're used to inside of Node. Here's the Swagger interface. To get to this, just fire up Composer REST server from the command line and then navigate to 3000/Explorer. You know, you can do pretty much anything that you need to do in here. It's a great jumping off point for anybody who's going to be writing code against your RESTful API for it. So that's it. We were able to get it in production very, very quickly. A couple other thoughts. one thing that's worth pointing out is, like I said, we were using .16. IBM's platform, by default, it's using that version. So it's it's a little tricky to, you can get .19 instances up, but it just takes a little bit of hand holding. We're in the process of making that upgrade ourselves right now. Again, in their own documentation for releasing to their blockchain platform, they make it clear that they're only compatible with .16 at the moment. But again, if you sort of go off script a little bit, you can get the latest release to run. And just as a side note, for those of you who look at this thing after the fact, I wanted to point out where the connection profile data is to set up your access files for your business network. It's not super obvious where this is, so I'm putting this in the slideshow, so when you come back to this, if you set this up yourself, it'll be easier for you to find. So the future for us, we're using Fabric now. We're looking into Sawtooth as a possible alternative. The nice thing is that Composer works with that as well. We liked Sawtooth because it's got a few security features that we like. But really, just in terms of what the future looks like 6-12 months from now, there's also a pretty good possibility we'll be integrating with other industry ledgers. There's an ad ledger initiative, but really the way that our code is set up, since the blockchain component of this is sort of plugged in on top of everything else, it's modular, which means that we can plug into pretty much anything. That's it. Any questions?
Can you say a little more about the difference between Fabric, Sawtooth, and Hyperledger?
So I've slept since then, so I can dig up answers to that for you. The main difference that I can point out off the top of my head is that ad ledger, I don't think that they've necessarily picked a platform that's going to be on. It's more of a spec at the moment about what data they'd want on a blockchain. So that's sort of in flux right now. But yeah, I don't have it right to be able to just.
So they're not software packages necessarily. They're like a protocol or a way of organizing your data.
Oh, you mean Fabric versus Sawtooth?
Yeah.
It's a completely different blockchain.
Okay.
Is my understanding.
Sawtooth also uses Intel's like predictive enclave stuff, so they have some like story around how like you can have different values of users or data that doesn't live on the blockchain that can't. So actually, it's an actual non-public part of the blockchain.
It's on one computer.
Yeah, like Intel. I think Sawtooth itself is like an Intel thing, like the.
Yeah, they were the ones that developed it.
Yeah.
Yeah, but it's not constrained to one machine. I mean, it's like it's distributed like anything else.
So I think it only works on Intel-based nodes. I think. Like
Oh, that may be true. That might be true. Yeah.
Alternatives to IBM blockchain. Did you look at anything else? Did you go over those details?
Yeah. So when we were thinking through this process, we knew that we could stand it up on our own hardware. I mean, there was nothing stopping us from doing that. Two things made the IBM choice very appealing to us. One was they're a potential partner. They're also a potential client. And the way that their interface is set up, if you're willing to eat the cost, it's basically push button. You press one button and boom, you've got everything set up automatically. You download your connection profile data, you plug it right into Composer, and you're done. So that was the fact that it was that fast was very appealing to us.
And how about performance-wise with using containers in IBM's platform? Is it better or comparative to like Azure or AWS?
Well, our experience probably isn't since we're using Composer, and the version that we're using is pretty much fresh off the griddle. It's quite a bit slower than I would expect it to be. So the numbers that you saw at the beginning that they sort of, and that others have put out there that are communicating directly with Fabric that they're seeing, our numbers are probably an order of magnitude less than that, but we expect those to bump up quite a bit. So it's not really, I mean, I haven't run it on those different platforms, but I'm not really, it is what it is.
It's mostly a conscious decision, possibly partnership with IBM more than making it cloud agnostic for other
Right, at least for us. At least for us. Right. Now we've stood up clusters on their platform separate from their blockchain product because it's just Docker containers. But in terms of like benchmarks and comparing those to other platforms, I really don't have numbers for you there. At least not at the moment. I mean, once we start having other clients who want to plug into this, and we get a little bit farther out, we're starting to look at things like, maybe solutions from Oracle because they've got a competing they've got a competing Hyperledger Fabric platform. So that might be interesting to see how those numbers shake out in comparison. But at the moment, what we've got works perfectly fine. Oh, one other thing that's worth pointing out is the data. Just to kind of put that in context, the data that we have. We talked about those chains: A buys from B, buys from C, buys from D. We're rolling up all of the impression data for those individual chains on a per hour basis. So we're only applying about 500 commits. I mean, there are thousands and thousands of these, but when we aggregate everything, we're only dealing with about 500 of these per hour. So it's fairly low volume. So in terms of performance, it's not as much of a concern for us.
Yeah. Oh, and one last question. In regards to the API, because you're using Swagger, did you look into using like GraphQL for dealing with like mass, like if you start expanding these besides the 500 queries, to kind of like get the data out there more efficiently and more effectively for other platforms to connect to?
Yeah, I mean, we've definitely given that a look. But again, right now, this is like we've addressed all the initial concerns, and now we're basically just waiting for clients to plug into it. They continue to say that they want to, but they're basically their own internal blockchain initiatives are lagging fairly far behind where we are, and so it's just a matter of waiting for them to catch up. At that point, then we start building real applications. Like our application is real, but the blockchain component of this is the part that it's sort of still relatively nascent. But when we get to that point, then we'll certainly start plugging stuff like that into it. Yep. Anybody else? Yes.
This is not really on topic to your presentation, it's more general. But what would you say to there seems to be a bunch of, an argument about private blockchains that you could just do that with a database. It seems like you got a lot of a benefit of having this tooling so like, ready to go.
Yes.
What would you say to that argument? Like, you could do it in assembly language too, or like, do you have a better argument?
Oh, like private. Like, why would you even use blockchain?
Right.
Yeah. So we continue to ask that. It's really about where the market's going. We know that we think it's definitely where things are going to be a couple of years from now. So we want to make sure that we've got everything in place that when folks want to do that, it's there. Because the reality is these people don't trust each other. They trust each other enough so that they're willing to communicate through some kind of sort of shared resource. But at the end of the day, they distrust each other just enough so that something like this is necessary. Now, if they were the only ones putting the data on there, then you'd have issues, right? Because you can just as easily put fake data or false data onto a blockchain. Like a blockchain doesn't magically fix those kinds of problems. So that's where we come in by validating all this stuff through multi-dimensionally, so that by the time it lands on our internal ledger, before it gets pushed to their shared ledger, all of those issues have been resolved, and they know that the data that's landing there can be trusted.
But if let's say you tried to build this like 10 years ago with like a REST API, PHP, and MySQL, how much more effort would it be?
Well, given that, you mean the blockchain part of it, or what we're trying to scratch, the itch we're trying to scratch there?
If the interface that your client saw was still the REST APIs, and there wasn't actually a blockchain on the inside, would you still be able to accomplish the things you're accomplishing?
I think so. Well, the only thing, the piece of this that was essential that we borrowed from blockchain that we run at scale are the digital signatures. I believe that technology existed then. It just wasn't in the mainstream sort of conversation.
Put all that together,
Yeah.
and sort of there wouldn't be like a platform you'd be using. You'd be inventing a platform.
Well, the part of it that's completely divorced from this, the stuff that runs at scale again, the part of that that would have been less mature then is specifically the hashing and signing of stuff. But those technologies existed. You would have seen an evolution over time. Like if we started this company, or if this company existed magically 10 years ago, we would be able to do all the things we needed to. It would have taken a little bit longer, but not like an order of magnitude. It would have been like incrementally more difficult, but just because we would have had to have done the investigative work to have found the pieces that we needed to glue those together. But then once it was all together, it would have run more or less like it does now. Yep.
So how much data are you crunching?
Well, we're dealing with, actually, we may have some of our, no, they're gone now. I was going to say our ops guy was back there. He could have told you very specifically. I want to say terabytes per day. Because it's ad tech, we need to be able to process millions of transactions per second. And so, we're tooling up, and we're in a position now even, I mean, we've run tests where we're able to, we should be able to scale based on our tests into the petabytes, So we're, given that at any point, some of the larger companies that we're looking to land could say tomorrow, let's do this, let's get it turned on by the end of the week. We need to be ready for that. And so actually, I didn't see you. You moved over here. So you want to talk about how much data we're processing right now?
I don't know, man. Yeah. I wish Joe was here. We do have a nice dashboard with that one number that you're asking for. I'll have my eye on it.
But we're dealing with a fairly decent amount now, and we're tooling up to be able to handle perverse amounts of it. I don't know if that answers your question specifically enough, but
The backend for the data structure, how is it being inserted into the blockchain?
so the data lands right now. I'll sort of walk you through how it gets digested. So it lands now in log files that get consumed. Actually, this is something that Noah could speak to. So correct me if any of this is wrong. So the data lands in log files. Those log files get consumed into SAMSA, and from there, they're sort of aggregated on the fly. And at the end of that data pipeline, after they're fully digested, they're injected into a sort of MySQL-ish type database. At that point, it's fairly compact data, because again, we're only dealing with the combinations of buyers and sellers and middlemen. There's only so many of those, so you're only looking at tens of thousands, maybe hundreds of thousands at the most at this point per hour of those, and so that's pretty compact. And so what we're doing is we're taking that data, chunking that up into blocks of 100 chains a piece, and then putting those on the blockchain. Yep.
The Hyperledger itself, is it saving those files, like the block files in level DB, blocks or files, or is the backend pluggable? Do you can you say, because it's completely controlled environment?
Oh, right. The underlying database, I believe, is level DB. They've got support. They may have it now, actually. They've been talking about it of CouchDB, which would, because then you can just talk directly to that if you'd like. I wanted us to be running on CouchDB, but I want to say that's what it was. At the time that we initially deployed to IBM's proper sort of blockchain platform, they only had level DB support, but it sounds like CouchDB is either implemented now or it's any time now.
How many nodes do you have writing through it?
Right now, let's see. I want to say we've got 3 or 4 orderers, 3 or 4, and 3 or 4 peers. I mean, there's not a lot there, but the data rolls up nicely, so it's we don't really need a lot of nodes to support what we have.
So the premise of this blockchain is, you're saying, is transparency. So if I'm part of this transaction as an ad buyer or ad seller,
Mm-hmm.
what is my experience to gain insight into this transparency?
Right. So right now, the experience that a buyer has, let's say I'm Colgate, and I buy $1 million of ads on Super Bowl Sunday. I get reports on the money that I spent, let's maybe 30 days after the fact, 60 days after the fact, and that's from my agency, who's getting that data from their DSP, and beyond that, you have no idea what's really going on. So what our data provides, and so folks like that have used auditing services that get logs from each participant, and then tried to cross-compare those to kind of put together the sort of picture that we're presenting to folks. But they're wildly off. They're like 30, 40, 50% off. They can't account for where the money went. And so they've had to satisfy themselves, brands like that have had to satisfy themselves with a very, very incomplete picture. Because our data is accumulated on an impression by impression basis, just to give you a sense of how much more correct the data is that we're able to bring together. We had a very big client that moved, was it like Noah? Was it like $100 million through? It was a lot of money. Yeah, it was a very large number. This very large number, the difference between what they spent and what we were able to track of, the difference was only $11.
So what's your technology in place to query the blockchain to present that report?
Well, the blockchain, we're not really using the blockchain for that kind of reporting. We're keeping all that sort of as a conventional app where you've got a database that you're used to, you've got tools to query that database like you're used to, you've got UIs that work the way that you're used to. So in terms of the transparency that's there, just to finish the answer to the initial question, they're able to see that we tracked all the money, and they're able to see beyond that first hop. So they can see not just the DSP that they bought from, but they can see the SSPs that were one step beyond them, and they can see every single domain that those SSPs bought traffic on. But what was your second question, or second part of that question?
Well, so the blockchain is the foundation of this transparency. So now as a non-technical ad buyer or consumer, how do I leverage that transparency by getting reports off this?
So how do they use the information they've got?
Yeah, and then what's the technology that kind of serves that information to an end user?
Well, the technology is it's whatever it's Java, it's RESTful APIs as far as that part of it goes.
Querying the blockchain, or are you saying
Well, so there's two different pieces of technology. There's the piece that we're using to actually aggregate the data and write it to our database. That's all fairly conventional. That's not blockchain at all. We're using components of blockchain, the digital signature portion of it, so that when a party is sending us financial data with for a particular impression, they send an API call to us, and that's digitally signed with their private key. So that's sort of where and they send that along at each hop. So the last one in that hop sends that to us, and then we can see that each participant has signed their portion of the payments. And so that's the blockchain-ish part of that side of things. But as far as how the data lands with us and then how we process that, that's all very sort of typical in that sense. As far as how so in terms of being able to see into the data, they're able to get all that transparency, the value of that transparency from that side of things. The blockchain part of it is where they want to be able to see, they want to be able to audit the numbers from this side of the house. So somebody, let's say it's Colgate's buying from Wall Street Journal, and so that data's on the blockchain. We've already processed all that payment information. It's over there, and they want to, let's say maybe they want to have contracts. They've agreed to some kind of contract that if a certain degree of viewability isn't achieved, so let's say 50% of those ads aren't visible, then there's going to be some kind of discount that's at play. They can create those rules between each other without ever talking to us. But the data that gets fed into those contracts would come from us, and that stuff would be what would live on the blockchain. So on that side of things, you get the automatic reconciliation, you get all those kinds of automated contractual features. That's what lives over there. The transparency is over here, and it's nice and fast and sort of old and boring technology. As far as that goes, the blockchain-y part of it is where the contracts and that part of it happens. Does that make sense? Okay.
So that means you only use the smart contract of the blockchain, not. So what kind of data will save in the block?
The payment chain information. So that information, like we showed that like the second or third slide where it showed A pays B, pays C, pays D. So it will record that entire chain, the amount that was paid at each hop, and any other special information that we have about that particular transaction. So it might be like which website or which websites those particular buyers were buying from, and in any other data that we want to sort of annotate that chain with can be sort of rolled up in aggregate for that particular chain on the blockchain.
So I saw you have login function, right? You have username, login, password, something like that.
Mm-hmm.
So all those information is stored in DB or in database or in blockchain.
For the ask that question again.
User login
To log into
to
our interface or to have access to the blockchain or which?
the blockchain.
Let's see. Let me think about that for a second. On the blockchain side of things, it's all handled with which kind of keys are those? They're not SSH keys, but they're very similar to that. So that you're using sort of public-private key type of authentication as opposed to, there's no like username and password. It's nothing like that. Although, so that's true for the blockchain itself. When we get to talking about Composer, actually I think Composer uses very similar authentication too. So it's probably the same for both of those in terms of accessing the data. Well, so we've got these two pieces. On this side of things, where we're talking to the blockchain, all of that's handled with public-private key type of stuff. On the on the UI side, where we're storing all this data in something that's very much like MySQL, that side has sort of typical username and password access to the UI that then has access to the underlying data.
How do you make sure all the parties you need along the pipeline, will join your blockchain?
Oh, how do we make sure that we get them involved? We have the advertisers who have all the money put lots of pressure on them. So all the clients that we want to integrate with, and that's where all the money's coming from. So we get them very excited about our product and then have them put the appropriate amount of pressure to have the folks downstream from them integrate. And it seems to be working. So.
Is it working for all the parties? What if one party just don't join? This one doesn't work.
Right. So the one piece that we have to have at this point is the SSP. So we have to have an exchange or an SSP integrate. But the good news is there are very few of those. So even if we can flip one of those, we're in a good spot. So we've already integrated with one of the largest exchanges out there. So we have them as sort of a backbone for the rest of this, and we're in the process of flipping. We've got a few DSPs that are coming on board, and we've got a couple other SSPs that are sort of similarly getting on board. But it's a long, slow process because these companies are humongous, and there are a few other things that happened this year. We had GDPR that happened this year. I don't know if you were familiar with that. You probably got your inbox was probably inundated with emails from companies saying, please let us still send you email. Like that whole initiative that came out of Europe slowed this whole process down because the extra time that those companies might otherwise have had to integrate with us, they've been spending just fiddling around making sure that they're GDPR compliant so Europe doesn't sue them out of existence. So that's been one thing that sort of slowed things down a little bit. But that's how that integration works.
And also, your company is centralized, right? So how do you make sure that the parties, how to say, in the future they trust the data because your part is not distributed, it's not decentralized.
Right, we're not decentralized right now, right. Well, I mean, really it comes down to people. I mean, I could give you a technological answer, but the real answer is a people answer, and that's our CEO, Will Luttrell, was also, before he worked here, was also a founder of a company called Integral Ad Science, and their whole value proposition is detecting fraud. And so he spent close to a decade building that company up, and they're one of 3 companies that are like the go-to companies for if you're a company who's doing business online advertising wise, and you want to know whether or not real users are seeing your ads, whether they're viewed, whether they're bots, all that kind of stuff. That's the technology that he built there. So he built and Chris Chapman, who's also one of our founders. The two of them essentially built that company, and the industry wide knows these guys as people that they can trust, all those kinds of things. And so that's really where a lot of this comes from in terms of people trusting that we're not another company that they can't trust.
But what if your server is compromised?
What if one of our servers is compromised?
Yes.
I mean, it's not going to change. It's not going to change the data. I suppose someone could change that data, but then since we make it easy for people to audit their own data, it'd be very easy for that kind of thing to be detected, either by us by double checking our own data against data we already have, or third parties, our clients double checking it. Yes, that's the other thing. So I was speaking more of the stuff that's already sort of aggregated. The underlying data you couldn't modify, at least not without it setting off a million alarms.
Yeah, what he's talking about, like, if one of your containers is compromised and correct me if I'm wrong, if your data is actually manipulated a certain way to get from the blockchain, then it could be, is that what you're trying to get at?
You can continue.
Okay. All right, yeah, because then if someone would actually take the ledger and see that and try to plug it into whatever the system was, something would actually break and you could actually just drop it. So you could build out rules for kind of like checking this kind of things. So I don't know how difficult it is because I never programmed blockchain, but that's how distributed systems would technically work.
Yeah, you could do that, and we also have code in place that constantly checks the signatures against the underlying data. So if either the signature changes or the data changes, then that particular payment chain is invalidated.
And how does that work actually just from a compliance perspective? Are you strict with audit because of how it's payment on blockchain, or is there like different regulations?
My understanding is even though we're not a bank yet, we're trying to come at it from we might be a bank, just to make sure that we're as compliant with those kinds of rules as possible, so that when we have a company like let's say an AT&T or an IBM or whoever that's humongous, they're going to look at us and say, okay, well, prove to us, let's do a security audit or what have you, that we're already a step ahead and have all that stuff in place. So we're very sort of strict with ourselves as far as that goes.
So does the blockchain actually resolve a discrepancy where one of the middlemen says we placed an ad with this publisher on this date and the publisher says no they didn't?
So the way it's set up, a lot of this, at least with our current implementation, a lot of this stuff falls out before it could even possibly land on the blockchain, and that's because these parties sign it as they go. So everybody agrees that it really happened. The only piece, to your point, the only piece that I wouldn't say it's missing, but that may not be necessary, is the publisher piece. And the reason why is that because and that's kind of the second part of this. So we gather all this data, and that's great, and we give people all this transparency. But it'd be like if the IRS couldn't come after you if you didn't pay your bill, or if you said you were going to pay somebody but then didn't actually write them a check, kind of like you owe them but then you don't actually follow through. Our system actually, since our system supports the payment piece of it, if I say I'm paying the New York Times, for example, for a particular payment chain, they're the only ones that are going to get paid. So the only people that get paid are the people that are actually integrated with us. And for the most part, the people that are integrated with us are good actors. So to a certain extent, once we become somewhat ubiquitous, at least in terms of people that are playing by the rules, the only people that will be within our network will be people who are actually behaving themselves. So that's sort of a super high level answer to your question, but the answer down here is that if somebody's paying the Wall Street Journal, they're the ones that are actually getting paid. So if there's, because I think what you're asking about is sort of like if there's spoofing involved, like maybe you've got a website out there. Well, here's the example that I usually use. You could conceivably set up an iframe on Pornhub and serve ads that you claim are being served to Wall Street Journal, but they're hidden in an iframe. So you get all that money, and since you can set up an account with one of these guys with a PO box, there's no accountability. You get all the money, nobody knows. But with our system, if somebody says they're paying the Wall Street Journal, they're literally, like, to even get the numbers into our system, they would have to be paying the Wall Street Journal. So it takes the incentive out of fraud almost completely. Did I answer your question?
Pretty much, and I was just trying to understand, you know, you're saying 20 to 30%, I think, of payments could be tracked, maybe more.
Right.
Where were those payments not going before that they are going now? Or the actors that were doing that aren't part of your system because they know they're going to be caught?
Yeah, it's most of that goes to folks charging more than they claim they are. So somebody says, "I'm only going to charge you $9, or I'm only going to charge you 9% to get access to the media that or the ad inventory that I could sell you," and in fact they charge much more than that. Or they charge you, like, to get the numbers there, they do the spoofing like I mentioned, so that they can get the numbers into their system, but then none of it's validated, and so you get charged for something that a publisher can't verify that it actually got served for. So that's kind of where all that comes from, different ways.
So I don't know too much about the IBM Hyperledger. So the IBM still use the concept of nodes.
Mm-hmm.
So how many nodes you have in your system?
Yeah, I think who else answered that question? Somebody else asked that question earlier, but it's only about 6. There's not that many.
6.
And that's because all the data, since it's pre-aggregated before it gets to the blockchain, there's just not that much.
Okay, I have built a small blockchain, so I only have 3 to 5 nodes. So if you shut down all those nodes, so all data will disappear, right?
For the data that we're putting on the blockchain, yeah.
It will be disappear. So
Yeah.
Right now you have 6 nodes.
But again, keep in mind that there's sort of 2 halves to the company. There's the part over here that gathers all the data together, and then to make it available for clients to share between themselves, we put that data on the blockchain. So let's say a bomb goes off at IBM and all that data is lost over there. That's fine. All the data that's over here, we can basically fire up a script to completely recreate the entire thing if we needed to, yeah.
So it's general question. Do you have an idea of how many data blockchain can hold? Because there's no database, so it's not writing on.
Oh, like how much it could hold?
Yeah, how large of the data can hold?
I'm not really sure. I know that when we initially spec'd it out, it would hold what we wanted it to, but that number doesn't readily come to mind. I'm not sure if there's really a cap to it. You just keep throwing more hard drives and machines at it.
How about the process? I mean, if you have a blockchain database, you want to search some data. So how is the speed to, let's say, search something?
Yeah, I don't have recent benchmarks for that, but it's sort of in the same ballpark as the write speed, at least for what we were doing. So at least a few hundred per second, and probably in the thousands, I'm guessing. But again, that's talking directly to Fabric, and we've got this composer layer over the top of that we know is slow because or slower than that. But that's a solvable problem, and they're gradually fixing that issue. But it's perfectly fine for our needs. I mean, most people, I don't know that a lot of people are writing faster than a couple thousand a second. I mean, anything else?
I wanted to ask you just one question.
Sure.
Unless you're planning on starting a business about this, you want to keep it to yourself. Any predictions or ideas for what other, I guess, where this sort of approach or another blockchain-based approach could be used to innovate another industry?
Repeat that again. I was having a hard time hearing you.
Just other business use cases
For blockchain in general?
Do you have a favorite one?
I mean, most of the ideas that I have for what I think are really good uses of blockchain are really boring. To use the same term that they're using with Hyperledger, this idea of an asset, just tracking stuff, selling cars. Yeah, inventory management. I mean, it's not sexy at all, but I think that's probably the best use case for it, because you just want to make sure that this car, like there's some way to sort of hash physical objects, and there's technology for that. To say this car is really the car that you're buying, that the VIN numbers haven't been changed, things like that. Diamonds maybe, I don't know, just stuff like that. Just physical objects changing hands, real assets being bought and sold. There's some talk about using that kind of a thing to make sure that the organic fish you're buying is really salmon from wherever you think you're buying it from. But again, that's less. I think there's less value in that than the car thing, just because you can put fake data on the blockchain. So unless there was a way, there's not really a good way to sort of like hash something that's that perishable. So that's kind of, you can just put fake data on there for that. But for other things that are a bit more permanent, I could see there being some value. But again, it's not like, cool. It's just useful. Yep. Thank you.